Let us understand another important concept, shifting of force to parallel position. How to shift a force to parallel position. To understand it, we have to go through two steps. First one is we should understand that any kind of force system, it may be any kind of force system, any kind of force system can be converted into a single force and a single movement at a selected point. For example, this is a rigid body. Forces are acting like F1, F2, F3 and F4. We wish to shift all these forces to O point. Now the distances or the location vectors are r1, r2, r3 and r4 with respect to O. So we can calculate what is Fr. Fr is nothing but summation of Fi's. We can add all these forces to find its resultant effect. Resultant translatory effect can be added and described by summation Fi's. Similarly, we can take moment of all the forces about O, like R1 cross F1 plus R2 cross F2 plus R3 cross F3, and we can find out the resultant movement vector, that is Mr. Mr is nothing but summation of Ri's cross Fi. So the net effect of this is one translation and one rotation at the selected point O. That is, we can convert any kind of force system into a net translatory effect and net rotational effect. Now, if the angle between the resultant force vector and resultant movement vector is 90 degree, then this system can further reduce to a single force. How it can be done? If the angle between Fr and Mr is 90 degree, it can be converted into single force parallel to Fr such that R cross Fr is equal to Mr. We are supposed to select R such that this equation will get satisfied. So Mr is coming from here, Fr is coming from here, R is required to be determined. Now this figure has been redrawn here. Now the angle between these two vectors, let us assume that is 90 degree coming for the particular case. So we can shift it from position O to position A, parallel position, such that Fr will remain parallel to original force Fr at distance R. So what is here? Mr effect is also taken by the effect of Fr, because if you see the movement of Fr about O, it is R cross Fr. So that is what the same effect what is coming out of this Mr has been taken care of by shifting it to a parallel position. So any kind of force system can be converted into a single force and movement, and it can further be converted into a single force parallel to the resultant force at a selected point. This can be quite useful in many of the numericals for converting the force into couples or converting force into a single force.